Hi everyone, this is Mr. Mohammed, and today we're going to do some rationalizing of the denominator. But what that means is we actually need to get rid of the square root in this problem from the denominator. So we want the denominator to be a free place from any square roots. And the way you do this is by making some changes that somehow will make the square root disappear. And we've talked about this before. If I want to use this rule, if I have the square root of x and I multiply it by the square root of x, it's gonna be x times x is x squared, and of course they cancel each other out, then you end up with only x. Another way to look at this is by having x under root as x power half times x power half, and then when we multiply we just add the exponents, so that's x power 1, which is x. So there are many ways to look at this. So in this case I have a problem. The problem is the square root of 5. So if I multiply the square root of 5 times itself, I will end up with the square root of 25, or the square root of 5 squared, which is only 5. So with this little trick I make the square root disappear. So we're going to apply the same method here in this problem. In this problem I have square root of 5 underneath. So I'm going to multiply by square root of 5. Because when I do this I will end up with only 5. However, if you multiply by square root of 5 in the denominator, you have to do the same to the numerator, because you can change the balance. So I'm going to multiply by the same root of 5 in the numerator. So that means just like multiplying by 1, root 5 over root 5 is 1. But what that does is you have square root of 500 times the square root of 5, so you multiply what's inside. But I'm not going to actually multiply, I'm just going to make it 5 times 500. Okay, and underneath I have the square root of 5 times the square root of 5. We've done it before and the answer is only 5. Let's simplify it a little bit. And by the way, this is done, like here until this stage you have already rationalized. This is khalas, done. So you've done that. So the denominator has already been rationalized. The problem is you just want to simplify this as much as you can. So 5 times 500, it's like 25 times 100 under the square root, and under that I have 5. The square root of 25 is only 5, times the square root of 100 is 10 over 5. Let's simplify by cancelling 5 with 5. You end up with 10. So the answer, or the simplified version of the square root of 500 over the square root of 5 is only 10. This is the simplified version. Alright, but let's see if this stands true with the cubic root. I mean, if I multiply the cubic root by itself, would it disappear? So let's have a look. Any cubic root, let's have the cubic root of x times the cubic root of x. This would be just like x power 1 over 3 times x power 1 over 3, which is x power 2/3. So the cubic root actually did not disappear, because this is x to the power 2 and the index is 3, right? So that's the problem. So we can do the same as we did with the square root. So, but if you think about it, it's just like multiplying cubic root by itself 3 times will do the trick. All right, so what we need to do, so I'm going to erase this right here. What we need to do is multiply by itself 3 times. But even better, if you think about this, let me just bring this a little bigger, like this. Okay, so if you think about it, if you were able to multiply the denominator by something that will make what's inside the cubic root power 3, because as you know, the cubic root of x power 3 is only x, because the index and the exponent, they cancel each other out. So it will be the cubic root of 2 is power 1. So I need to multiply it by 2 power 2 to become 2 power 3. So that's what I'm going to do. So I'm going to multiply by 2 power 2 times, here I have x squared inside the square root, so I need to make this something to the power 3. That's x power 2, so it needs only one more x. So multiply that by x power 1. And then y, I have only y under the cubic root, so I want this to be y power 3. So you guessed it, you multiply by y squared. Okay? And whatever you do to the denominator, you have to redo it to the numerator. So I'm going to go back, do the same exact thing. 2 squared times x power 1 y power 2. And let's see what this does. So this is going to be equal the cubic root of 2 times 2 power 3, which is 2 power 3, x power 2 times x power 3, y power 3. And up, I have the cubic root of 250 times 2 squared. 250 times 2 squared, just like 250 times 4, which is 1,000. 1,000. X power 7 times x is x power 8. And y power 3 times y power 2 is y to the power of 5. But what this does is magically solving your problem. How so? Because y power 3 under the cubic root is just 1, cancels. X power 3 under the cubic root cancels, 2 power 3 cancels, so the answer has a denominator of 2x, y, and they cancel out with the index 3. So our job up till here is already finished. We're done. We don't need to simplify further because it's over. But what we need to do is to find just the simplest form of this radical expression. So 1,000 inside the cubic root has a cubic root of 10, because 10 times 10 times 10 is 1,000. X power 8, I can take out how many x's? So I can take x's that can be divided by 3, can divide it evenly by 3. So 8 power 6 can be divided by 3. So x power 6 divided by 3, that gives you x squared outside. Y power 5, I can take only y power 3 out of it, and it will be outside as y, and I will end up with the cubic root of x squared y squared. So I can't take them out. So let me erase this part a little bit and write it clearer. So it has to be like a small 3 on the cubic root. So simplifying this, so we cancel the xy with the y and the squared. 10 divided by 2 is 5, so you end up with 5x cubic root of x squared y squared, and this equal has to be a little bit up there. So this is the simplified version of the radical expression. See, looks much better without the denominator has a cubic root. Yep. So that's exactly how you do that. Always think about how or what can I do to get rid of the radical in the denominator. That's your golden question. Ask yourself that and you're settled. Good luck.